In this demo, I'm going to showing you how can we wrap the Microsoft's 5.3 vision model with the Hugging Face transformer library into the API inference server, which we can deploy into the AI core later on. Basically, the step I'm described here, you apply to any kind of a transformer architecture compliant model. In this case, we take the 5.3 vision, for example. Of course, you can take another transformer library from the open LAM leaderboard from the Hugging Face as well. In the homepage of this 5.3 vision model, we can have information like the what is the model architecture, the model size, and as well as potential type. You also come with some technical information. For example, how can we inference this transformer library as well? Here was the required package we need to install. And then you also having some description about the chat format, how would be we need to parsing together. Especially in this case, we need to have add the image tag into the user message. And then you also come with some sample inference code, which we have went through in the previous slide. How can we convert this sample inference code into the server, into API server? As you can see, it will be pretty much the similar, while they're having the dependent package, and then we have seen just now we import the same. And then in order to make this sample code as API server, I'm using the Fast API. Of course, you can also use a Flask or any other web server package as well. For the model ID, instead of hard code, we have introduced a variable name and model name, which can be passing dynamically. Let's say we see how can we roll the model and the inference the model. To doing that, I have wrapped all of them into one class and so-called chat model. So this chat model, how to roll the model, you roll the model from the transformer library auto model for casual LM. We do pretty much the same thing in the get model method. And then you were saying if the model is having not in the list yet, and then you will load the model using the same auto model for casual. The same, you will get the processor. We're going to use the processor. If you remember in the presentation, we say we define the interface to be the OpenAI compatible API. Okay, you see that we are going to having the very similar message body here, like a list of a message. And then as you can see, we having the for the user message, we're going to passing the an image URL and plus some command, some instruction, what is showing in this image on that. Look at the endpoint first. We would like to have in V1 chat completion endpoint. And then basically you are passing the check completion requires, and then will return the response. So within this function. So basically for this check completion request class and the response class, it's basically it's implement the class to represent the request body as well as the response as well. For that reason, also implement a set of class to accommodate with the typing, the PyDynamic library in this case. Okay, so the logic to inference the library as API logic was implemented in the general response here. You are using the check completion requires. As you can see, we need to having some to process the image, the test image with some image tag. So this is the code snippet have been doing the same thing. And then the same, we apply the chat template to this message as well, which is doing the same thing here. You will have passing the input. So you will, if the image, there was image URL in place, so you will load the image into the binary encoding, and then you are passing the image binary data as well as the prompt, which has been applied for the chat template. And then the same, we just prepare some of the important generation argument like the temperature, how random will the response would be, and then you are passing the input to the model for generation. Once having the general ID, I have to do some extra work is to calculate the token, the completion token, the total token, and just for the usage related one. And then it batch decode the output as well as a response as a text. And we do the same thing. And however, instead of the print the response, we need to prepare a response JSON and finally response back to the API in this case. And then last but not least, the server would be launched through the UV as well. And as you can see, we can very easily to convert from the sample code of transform model in Hugging Face into the API server in this case. That will conclude the demo.